First of all, thanks everyone for joining. And my name is Adam. So, what is this session all about? Now, all of us want to move to a better career like DevOps, whether you're a fresher or an experienced person or from a non-IT. We need to know as of now in the market, what are the expectation when we say that this technology called DevOps, right? And what are the things that we have to learn so that we would be able to showcase ourselves as a good fit to that position. And not only that, down the line, if you look for the next 4 to 5 years, you should be able to manage in that position. So that's where in this session, let's talk and understand about what is the current trend in DevOps. So what are the things that a candidate or a person would be working in DevOps, and what is the expectation from an organization? So from that perspective, what will be your roadmap to learn, and how do you convert yourself to be a successful DevOps engineer, right? So that's the whole point of discussion what we will have today. And before we proceed, now do like and subscribe our YouTube channel, because there's plenty of videos and all the recent webinars that we have or what we hosted is being there. And if you are a beginner to DevOps, there's a lot of self-learning videos for the prerequisites. That is something that you can go through and make benefit of it. All right. So with that, so when you go to an organization, now what we need to understand, like how they need people to work on developing a product or testing a product or maintaining some product in some environment like production. They also need a bunch of people to help solve different problems which happens in the software development lifecycle. So that is apart from your development, testing, or your maintenance, right? And this is where, if you go to a company, as a culture, DevOps talks about various automations that we can do through which a company can deliver a product faster, and at the same time, they can increase the quality of the product. And not just that, when you talk about certain products like e-commerce or your banking or social networking, it's not just about fast delivery or cost optimization. You need to make sure your application is always highly available and scalable, so that more and more users connect, your application should be able to sustain that. So that's where the main focus of organization adopting to this culture or concept called DevOps is for scalability, high availability, faster releases, and at the same time, the quality of your product should also be higher and better. So from this angle, like when you go to any organization, considering the different problem statements that they would have from beginning of the development to the time when the product is being maintained after the production release, so there will be various phases of SDLC. And for all those phases of SDLC, DevOps tells us to follow some best practices using which you can improve what we are doing. But for that, we do some automation and do use a tool for that. And this is where, as of now, whenever we say DevOps in an organization, there is around 9 to 10 concepts or strategies which a company will be using overall to help the faster release and, as I said, high availability and also scalability of your application. So this is where we need to first understand what's those 9 or 10 strategies which every company is following. But again, before even going further, there'll always be a question that, okay, so now you're saying a company needs to have all this strategy. So what will happen as an individual? Now, this is when DevOps is more like a buffet. So you go to a place, everything is there. Now, depending on your hunger and you like, you will eat something, right? The same way, an organization needs all these strategies to be implemented as of now. But depending on the team that you join or depending on the problem that they have currently, you might be assigned a couple of them that you have to take care of. But it's not mandatory that either you will be working on all of them in one go or you will be just working on one or two problems. Over a period of time, you will get newer challenges, and you knowing all these strategies will definitely help, so that from an organization perspective, we would be able to help them in any of these problem statements. And for each one of them, it's mandatory for us to be aware of what are those strategies that are there, which is on the current path. Okay. And that's when let's take some time to understand one by one each. So the first strategy which DevOps implements in an organization is called as continuous development. So what do you mean by continuous development? So whether the project which the company wants to deliver could be a Java based or a Node based, right? Or it could be some Angular JS based, any kind of tech stack they use. But we need to make sure that there is a fixed timeline within which everything is delivered. Now for that, developers have to write a code, but how is that we can help them? So what is that strategy which we have to adapt, which will help them to do the development faster and continuous, right? So that's when in continuous development, DevOps suggests to have a fixed timeline and allow parallel development to happen. So what do you mean by parallel development? So same product, for one customer, there might be a set of changes you are doing, and there might be another customer, a different set of changes you are doing. Or you might be doing a new release with some kind of enhancements for the product. So that's where multiple changes will happen at the same time, which is what we call it as parallel development. Okay. And in order for all the developers to work together, there needs to be a proper workflow. And that's when in DevOps, through the continuous development strategy, we ensure you're doing the development, but how do you make sure you're doing parallel development? And how do you make sure that there is a proper workflow in which all the developers do their code and it gets merged so that we can create a product out of it? And this is where we will be following a methodology called as agile methodology. Okay. Now, using agile methodology, DevOps implements the continuous development in any organization. Now, anytime when we say a strategy that DevOps is bringing, it can be automated only with helps of some tools. Now, it can be one tool or multiple tools. So that is where when you go to an organization, one of the first thing DevOps implements is continuous development. And in order to implement, you would be working on a methodology like agile methodology, plus there will be a lot of tools that you have to use in order to help the development team to work in parallel, as well as ensure that there is a proper workflow. And also we ensure that there is a proper authorization, because I don't want one developer to do some changes which is not needed by a customer where someone else is working. So how do you ensure all of this? So that's where it's not just about following an agile methodology, but also using certain tools which supports the version controlling. And that's where to support continuous development, most of the time, if you see current market, we would be using a tool like Jira, which helps us to track what we are doing in the agile, as well as you would be using some tools like GitLab or GitHub or Bitbucket to store and track all your changes. Okay. So that would be the first strategy which as an organization we have to adapt. And for that, now if you are going to be a DevOps engineer, so one of the activity that you would be doing is supporting all these activity by working on these tools. Okay. Now, so once you have solved your release requirements and allow developers to start doing their work parallelly, the next thing that comes into the need is, okay, where will the developer test their code, right? Or when we are asking QA to do a functional testing, where will they do the testing, right? Even once the testing is done, you need to run your application in an environment like production. Then where do you create it? So that's where, as of now, we know that the market has the infrastructure completely on cloud. But how do you make sure that whether you need a new infrastructure or you have to modify existing infrastructure depending on the need. It should be done immediately. Okay. And at the same time, I should be able to do it faster. Why? For example, I want to do a testing and I need some set of machines and database and some kind of network within matter of 1 hour, let's say example. Why? Only then I would be able to go ahead and do my development and testing. Same way when you go to production, when more load comes into your application, you cannot tell to the customer, you know what, wait for half an hour, I will add more machines and then you can use my application, right? Things has to happen instantly. So that's where, whether it is for internal work like development or testing or for a production environment, the infrastructure need might be new or modifying something existing. So this is when we need the ability to create the infrastructure faster, and at the same time, it has to be consistent. Why consistent? Every time when I try to reuse it, I should be able to get back the same quality, or my infrastructure should be in the same level. So that's how the second strategy which DevOps says to implement in an organization is called as infrastructure as code. So what do we do in this? So in this automation strategy, so we kind of define whatever the infrastructure that you need in terms of a code. So when I say code, it's not a programming language, but there are some certain syntaxes through which you can tell what you need. So now, for example, if you want an infrastructure in AWS, you don't have to go through the AWS console and click hundreds of buttons. Instead, you need to take some file and give a syntax which will be your desired infrastructure, and the automation that we are going to do through infrastructure as code will be converting them, and it will do the infrastructure creation automatically. So that's where, through this strategy of IAC or infrastructure as code, in a company, anytime we want, whether it is on AWS or Azure or GCP, we will be able to create or modify or scale our infrastructure automatically. Okay. So that's how DevOps helps the organization to take care of the infrastructure through this strategy called IAC. So this is when, again, when you now join to a company, regardless of whether it's a dev environment or a QA or a stage or a production environment, whenever there is a need for infrastructure, then you should be using the strategy or adapt to the strategy called IAC and help in automating the infrastructure creation. And now, whenever we say automation, then there's also tools. So in the market, if you see, for each of the cloud, there is a specific tool associated or a service associated. Like if you take AWS, there is something called as CloudFormation. And if you talk about Azure, then there is ARM or Resource Manager. But other than that, there's also some open source tools like Terraform, which can help you to implement the infrastructure as a code, and you can automate the infrastructure. So that's where now, using continuous development, we will help parallel development and allow developers to do the coding faster. And the second strategy is infrastructure as a code, through which we will be able to help in creating or scaling our infrastructure regardless of whatever the cloud it is. Now, the third one is configuration management. So now again, using infra as a code, you were able to create an infra. So for example, when we say create an infra, we are talking about creating a machine, creating a database, right? Creating a network. But what happens after that? You need to configure the machine so that you have some specific application or packages or services or a file available so that you can do a work. Because creating a machine doesn't guarantee that whatever that you need inside the machine is available. Once again, a machine using by dev will be having different configuration. A machine using by QA or in the production will be different. So this is when it is not sufficient for us only to automate the infra creation or only automate the machine creation. But any point of time, what we need is to make sure whatever the different servers that we are using, again, it's not only production, whether it is a developer machine or a QA machine or a staging machine or a machines in production. We need to make sure that the machines are always having the same configurations that you want. And even when you create a new machine, you should be able to automatically configure them. Okay. And this is where the third strategy in DevOps, which tells about how do you automate the configuration of different servers. Okay. Now for this, once again, like how you had infra as code, your configuration of a machine will be defined as some kind of code for which you will be using some syntax. So in this strategy, you give a syntax or a file which tells what is your desired configuration of the machine, and the automation on this strategy will take care of achieving it. So this is how, whether it is a production or QA, now suddenly when load comes in, okay, more customers are accessing your application or web application. One thing you have to do is first create infra or create machine. For that, infrastructure as a code will help you to create, but it's not sufficient to create hundreds of machines. Then immediately we will be using the configuration management or configuration as code strategy, and we will automate the configuration of all those hundreds of servers. So that's how we will be using a couple of strategies together to achieve end-to-end solution. Okay. So this way, configuration management focuses completely on how do you configure a new machine or a existing machine, but you don't worry about creating a machine, because creating a machine, a database and network is what infrastructure as a code focuses, and configuration management focuses on how do you configure the machine inside, right? So inside the machine, whether you have the application, what you want, whether the application is running, whether you have a file or a folder, what you want. So that's called as configuration. And now there are specific tools which will only help you focusing on configuring a machine. Now, as you can see the screen, there's a bunch of tools like Chef, Puppet, and SaltStack. But out of that, if you look at one of the popular and the recent most widely used tool is Ansible. So this is where in an organization, you will use infra as a code for creating the infra, and you will be creating a configuration management tool to configure the machines after it has been created. Okay, so this way we need all the three so far so that your organization can develop things faster, and whether it is for your development, QA, testing, or for your production, you create the infrastructure and configure those machines using configuration management. Now, what happens after that? Now, this is where stepping back to the development. So now you have the infra created, you have configured the machine, and developers are also doing the work continuously. But what happens between the development and testing? There has to be a connection, because in the continuous development, all we will be focusing is only allowing parallel development. So now, whenever developers complete the work, how do you make sure there's equally a testing which is happening in parallel? Because think of this way, I'm allowing hundreds of developers to work parallel. Okay, so they'll be just writing the code, but how do you make sure that we consolidate all those code together and make sure that my code is proper so that I'm ready for the production, which is where how do you make sure the testing happens continuously, and at the same time we should be going back and tell the developer in case if there is an issue, when can he fix? So that's when there is a need for us to integrate the continuous development with the testing, or in other words, how do you make sure testing to be continuous? Because for testing to be continuous, we need to give them the input. So what is the input? A product that we create. But for that, what do we need? We need developers to write the code. So this is where between the development and testing, we need to ensure a strategy which helps the testing to happen faster by taking all the latest code, whatever the developer writes, create a product out of it, and give it to QA for testing. So this is how this strategy called continuous integration kind of acts as a bridge between the dev team and the QA team and make sure whenever the developer finishes his work with the help of continuous development, immediately, how do you take the code, create the product, and give it to QA so that we can run the testing also. So through this, what will happen? Organization can now not only do parallel development, but they can also do continuous testing, and it will help us to determine the bug as soon as possible. And now, when you are doing continuous development and continuous testing, what will happen? Your quality of the product will be better, and you will also be able to deliver faster. Okay, so that's where now the fourth strategy which DevOps implements, which an organization has to adapt, is continuous integration. So which is kind of, again, a bridge between the dev team and the QA team. Now, continuous integration is more of a process which cannot be just achieved by one tool. So this is where you will be using a lot of tools like build tool, deployments tools, or unit testing tool. And along with that, you need one more tool which drives the entire process of end-to-end automation. Okay, and that's when we talk specifically about continuous integration, there are a lot of tools in the market like Bamboo, CircleCI, TeamCity, Travis. But again, one of the popular tools that you would always hear is Jenkins. So with the help of this concept called continuous integration, or a strategy called continuous integration, you can make sure that testing is continuous, and we will also be able to determine if there are bugs very fast, and obviously this will help us to do releases faster. Okay. Fine. And now comes another strategy. So we were talking about continuous development, infrastructure, configuration management, and how do you integrate development and testing, which is continuous integration. Now, usually continuous integration only focuses on creating a product which we can use it for deployments of testing or production. But eventually, whenever we say, I need to run my application or deploy an application, it's not going to be very easy. Now, this is where what happens. In production especially, you will be having hundreds of machines. Now, infra as a code creates 100 machines faster. Configuration management configures that hundreds of machines faster. But now, when you create a product using some process like continuous integration, now I want this product that we have created using continuous integration to be able to run or to be deployed on all these hundreds of machines immediately. Okay, and that's where in our traditional method, what we used to do, we used to take this product like a jar or a var or a zip file. We used to go to all these 100 machines, copy that file, extract it, do some changes or configuration, and then we need to start some application. Now that was a time consuming process, or it's more of a manual method. And that's where on the modern way, and one of the most critical and important strategy in DevOps as of now is containerization, which means rather than doing a traditional deployment, what we need to do is a deployment that can happen on 100 or even thousands of machines in your production or your QA. So you need a way on how do you do that, a faster deployment, and you should also be not worried about the platform, because a dev machine will be different, a QA machine will be different. So how do you make sure that your deployments are faster, easy, and regardless of the OS what you're taking? And that is where there is a new or a modern OS concept which is called as Dockerization. So what do we do in this? Instead of running your application directly on a machine, we create a layer called as container, which is created through virtualization. And inside that, you will be able to put all your application and run, so that anytime when you say you want to deploy or run your application, instead of you copying the file, configuring and running, you can just take this container and run wherever you want, which is easy to scale, which is easy to manage. So that's how in an organization, anytime when you talk about deploying your application, then we need to adapt to this technology or a strategy called containerization. Okay, so through containerization, you will be able to deploy your application faster and easy. And this is where, again, there are many tools available in the market. Okay, and out of all of them, still one of the popular tools that helps you to manage and create so-called containers is what we call it as Docker. And again, just like your regular virtualization, if you talk about things like VMware, you can create a VM, right? But for that, you need to take an image. The same way, when you're using a tool like Docker to create container, you also need an image which has a particular OS or a file. So this is when using a tool like Docker is one way, but you need a separate repository in which you will be storing all the images that is needed for your organization. And again, for that, there are different services available in cloud. Like if you go to AWS, it has a service called ECR, or if you go to Azure, there is something called as Azure Container Registry. If not, you can also have other tools like JFrog Artifactory and create your own registry. So overall, now, if you look at an organization, it is not sufficient for us just to build a product, but we need to create a deployable artifact or a deployable product, which is easy for us to deploy and which can be easily scalable. So that is where we need to convert our regular product like a jar or a var into a deployable product like a Docker image. So that's what is this concept or a strategy called containerization. So now using CI, you will be able to create the product. But after your CI, you will be adapting to your containerization, using which you will be creating a deployable product or a deployable artifact, which can be created as a container anytime, how many ever times that you want. So that's how now using containerization, you will get a deployable artifact, which is called as an image. And that is what we will be running it as a container or as the layer that I was talking about. Okay. So now we have continuous integration followed by containerization. But still, the next problem that we will get is, okay, containerization will help you to create an image of your product, which can be deployed anytime, anywhere. But we are not talking about just taking one machine or two machines and running. And this is when we have a group of machines, it will be difficult for us to manually track it. Okay, because let's say I know how to create a container. There is a command. But what if I'm asking you, okay, I want you to do this on 100 machines 100 times. Then you don't have time to go to hundreds of machines and keep running this command, right? Because in production, when suddenly a load comes, your infra as a code will create machine. Configuration management will help you to configure. Now, your CI will already give you a product, and Dockerization will help you to convert into an image. But that image has to be deployed on all these hundreds of machines. And that's when, on top of your containerization, we have another strategy that we have to implement, which is again one of the critical when we talk about production. So that's called as deployment orchestration. So in simple, what is that we want to do? We are not talking about deploying our application or a container on one machine. We are talking about hundreds of machines or a group of machines. So in that group of machines, we should not be telling where to create or how to create. And at the same time, when a load comes, we should not be telling, okay, I need another 5 copies of my application or 10 copies. So there should be an automated way where the strategy or the automation should know if more customers are coming, I should be able to create more deployments. And that's when the deployment orchestration concept takes the output, whatever you already have from the containerization, and helps deploying your application automatically on a group of machines. So that is how you will be able to scale your application deployment, because infra as code and configuration management will help you to give the infra. But inside that infra, given the image from containerization, you will be able to automatically deploy or scale your application deployment using this deployment orchestration. Okay. And this is where, once again, there are a lot of tools available in the market for managing your deployment orchestration of containers. But out of that, one of the tool or the most talked tool as of now in the industry that you see is Kubernetes. So this is how, using a tool like Kubernetes, you will be managing multiple application deployments over a group of machines. Okay. So now if you look, so whether it is your QA or production, there will be separate group of machines in which Kubernetes will be running. Now, anytime if you want to deploy your application, you will take the output that you have already obtained from the CI, and that has been converted as a Docker image using your containerization. So that's how the output of your CI and containerization will be consumed by the deployment orchestration, and the application will be deployed among a group of machines. So this is where, for an organization, you need CI and Dockerization or containerization, plus anytime you want to deploy it on a group of machines, and then you will be using the orchestration tool like Kubernetes to manage them. Okay, so that's what is your next strategy. Now, so we talked about CI, we talked about containerization. Okay, now we also talked about the orchestration, which is where still the puzzle is not solved. Why? Because on one side, if you see, continuous development happens, immediately your continuous integration will run, and then containerization will run. So now at the end of your CI and containerization, what you will have is a deployable product, which is a Docker image, as I said. Now, on the other side, you have your cluster, which is where Kubernetes is running. So now, how do I take my image, which is being built continuously? Because when we say continuous integration, you're not just going to run a project build only once. Now, every time when a developer modifies, you need to understand, I need to do a testing, because now, if I'm talking about testing, your testing will come only when the application is deployed inside a group of machine using orchestration or containerization. Now, this is where even for a QA to do your test continuously, development should happen, which is where continuous development. And after that, CI should run and generate a build. And after that, your containerization will convert it into an image. But now, every time when I continuously give a product like this, how will I automatically deploy it into a cluster like Kubernetes? And that's when there is a new strategy which DevOps says, which is called as continuous delivery. Now here, we will integrate the process called CI with the deployment, whatever that we are going to do. Because for Kubernetes, I need to give something like an image, only then it will run. But what I'm talking about is, you have a process where now anytime when a developer modifies, you are going to create an artifact or a deployable product. But how are you going to connect this to the Kubernetes? So that's what we call it as CI/CD. Okay. So this way, by combining this CI strategy with the deployment strategy, what happens? You get an end-to-end pipeline. With this, anytime in the organization, we can make sure that whenever a developer modifies the code, you will build the code, you will create a deployable artifact, and you will deploy it inside your cluster with the help of Kubernetes. And this strategy again is something not very new. It's there in the market when DevOps was introduced. But what's new in continuous delivery is, when you are doing the CI/CD, you want to do in a better way, wherein you have a better security, and it also covers various scenarios. Because the earlier stage of DevOps was focusing only on doing CI/CD for QA environment alone. But now if you see, I need to do the testing on QA, and immediately if I can get the ability to deploy to production, then my products can be delivered much more faster. So that's where there is a new approach called GitOps being coming into the market. Okay. So GitOps is a strategy once again where you don't have to sit and use all the tools and do everything manually. Instead, you're going to define some code as a desired state, and you just tell what you want through some files, and those files will be stored into a version controlling system like Git. And that's where there are now additional tools on top of your CI tool like Jenkins or Kubernetes. Because now, just to simplify, Jenkins takes care of CI, Docker takes care of containerization, Kubernetes takes care of container orchestration. Now, a tool like CI is not meant to do the deployment, and that is what traditionally we were doing. But now, introducing a new concept like GitOps, there are a bunch of tools in the market which helps you to do the CI/CD better, or to do the continuous delivery better. Out of that, you have tools like Spinnaker, you have Harness, Flux, and again, one of the other emerging tools that you take in continuous delivery or CI/CD in GitOps is Argo CD. So using this, you will be able to make sure that there is a continuous delivery for the company, whether it's QA environment or it's a production. So you kind of integrate everything so that now you think of a pipeline. Whenever a developer does a change with the help of continuous development, immediately you will have a process called CI, and that will automate the build. And immediately after that, you will be having the concept of containerization, which will convert this product into a deployable product like an image. And then this GitOps tool, whatever that you're going to use, will take that deployable artifact and give it to Kubernetes or the deployment orchestration. So that's how you will be able to do an end-to-end pipeline in a secured way. Okay. And that's where in the market, when you go to organization, they are not going to just expect you to do just a normal CI/CD, but they will expect you to do a CI/CD, which will help you to achieve continuous delivery, and which is what we use as of now, a GitOps approach for that. Okay. Now, okay. So now almost we talked a lot about how the application will be testing and it's being deployed. Now what happens after that? So especially now you have tested the product and you have deployed into production, then what will you do? So this is where an organization also need to make sure that for all these processes, whatever you are talking, whether it is continuous development, continuous integration, continuous deployment, or continuous delivery. Now for all of them, there are lots and lots of servers that you have used, or group of machines are there, or there will also be some lot of third-party applications that we are talking about. Now we need to make sure that all these machines, all these applications or services are always running, correct? Because just creating and leaving it will not be sufficient. And this is when in DevOps, every company also has to focus on how do I make sure that we monitor all these things. So that is where the strategy what DevOps says is, don't just monitor, do a continuous monitoring. What is continuous monitoring? Anytime, whether work is done by developer or a QA or something in production, you should be able to know whether the machines needed for that, or the applications needed for that, or services needed for that is running fine or not. If it is not fine, you need to take necessary action and fix. Only then your development will be continuous, your continuous integration process will run, your continuous deployment will run, and your QA will also do the continuous testing. So that's where using this strategy, we will be able to ensure you're monitoring all the applications, machines, and services. And not just that, we also need to have a place where your application logs are stored and kind of monitored in a proper way, because sometimes machines will be fine, your applications might not be fine. And if I want to debug or a triage an application, where is the log? If I want a log of last 5 days, how do I take it up? From where should I take it up? And that is when monitoring is not only for your machines and applications or services, you will also ensure that the application log is properly managed. Okay. And at any time, you also have a place to see that data, because another problem what we will be facing is, okay, you're collecting lot of data for monitoring, but anytime if I want, can you show me in a simplified way, like a dashboard, what is the utilization of a machine? What is happening to the machine? What happened to the machine in last 1 week or 1 month? And that's what we call it as data visualization. So especially to implement this strategy called continuous monitoring, organization has to go through lots of tools, because now there are specific tools to monitor your applications or machines. Okay. And the same way, there are specific tools to monitor your application log. And the same way, there are specific tools to visualize the data, that is through a dashboard. And that's where, as you can see the example, tools like Prometheus, Datadog, or New Relic will help you to monitor an application, monitor a machine, or monitor a service. But if you want to take the logs and manage the logs of application, then you will be using specific tool like Logstash, Fluentd, Elasticsearch. But if you want to visualize the data, see some dashboards and metrics, then you will be using tools like AppDynamics or Kibana or Grafana. Okay, so that's how it's a combination of tools which will help you to do continuous monitoring of your machines and services. Now, what else is pending? And this is where, as of now, the current market is not just talking about CI, CD, or it is not just talking about monitoring. There is one more emerging strategy which is added into DevOps, is called as DevSecOps. In simple words, security at every level. Because now in DevOps, what are the strategies we talked about? We talked about continuous development, infra as code, configuration management, CI, CD, or CI/CD, which is continuous delivery, and continuous monitoring. Now, this is where, how do you ensure that there is a security at every level when a developer does the work, or a QA does the work, or when we create the pipeline, or when I monitor my application or deploy my application. So this is where in DevOps, this new strategy called DevSecOps will ensure that there is a security at every level of your product, as well as the infrastructure, as well as the monitoring side. So this is how, by enabling security at every level, you can make sure that your product quality is good, your product is way secure, and not just that your product, but the infrastructure in which you are running the product, that also has to be secured. Not only that, you're talking about containerization and creating a deployable product, right? Even your images like Docker images has to be secured. And that's where it is not just about using IAC or using configuration management or doing CI/CD. We need to make sure at every level our product is quality, it is secure, your Docker images are secure, your Kubernetes cluster is secure, and the infrastructure that you're creating using a tool like Terraform or Ansible is also secure. And this is where your DevSecOps is not once again about one tool, because for different kinds of security, there are different tools. And this is where what we will do in DevSecOps is, when you are working on all the strategies, you will be having a specific security related tool which you will be adding. For example, now if you are focusing on improving the quality of your product, and if you are adding the security for your CI or CD. Then along with Jenkins and Docker, you will also use some tools like SonarQube, dependency check, or Fortify. So that will help you to improve the quality of the product. Same way, it's not again just to create a product. You also want to make sure your product is secured. Then you will be using some tool like OWASP or OWASP ZAP, using which you can do some tests like SAST or DAST and ensure that your product is secure, not just the quality. Then if you are talking about creating an infra, so that's where whenever you use a tool like Terraform, you also need to make sure that infra that you created using Terraform is secure. So on top of Terraform, you will be using tools like TerraTest or Checkout to make sure that the infra that you have created is secure. And same way, now when you create a product and create a deployable artifact like a Docker image, that also has to be secured. And that's where there are specific tools which can help you to scan those images like Clear. And what else? Now, talking about tool like Jenkins and talking about tool like Kubernetes, there will be a lot of sensitive data that you have to store. So how do you make sure that all those are again secured? And that's where there are certain secret management tools like HashiCorp Vault, or you can go to any cloud and they have certain services to manage the security or the secrets. Using that, you will be enabling the security. So that's how in the market, once again, it's not just about using a tool like Terraform or Kubernetes or Docker or Jenkins. You also need to make sure how is it secured. Okay, and that's a new strategy which market is looking into the DevOps. Okay, so now pretty much we spoke about 9 strategies. Is it the end? No, there's one last thing that you need to know, because earlier what happened, there used to be different teams. So there used to be like a separate ops team who will be taking care of all the system administration, networking, and there is to be another team with the product who is to do all this automation. But as we are moving everything to cloud, we need someone also to take care of the cloud, because when I talk about using IAC or infrastructure as a code, and I'm creating something like a machine or a database, so it is not sufficient for us only to know how to create a machine. But now we should also be knowing, for example, if it is AWS or Azure, what exactly should I need to do to create a machine? And what will happen after I create a machine? How do I maintain a machine? Suppose if I want to create a database, do you know what kind of database to create? Do you know how to make sure that the database is secure in the cloud like AWS? So do you know how to take backup of them? Even if a machine crashes, do you know how do you deal in managing? So this is where in DevOps, the new strategy which companies are adopting is do all the operations by yourself. So what do you mean by operations? Now here, we are still not talking about administering. If you want, you can do, but if not, apart from administration, you will be using lots and lots of applications, right? Lots of tools. Where are you going to run all of them? It will be on the cloud. So you should be able to take care of those infrastructure by yourself. A simple example, I give you a laptop. If you need to do certain things like fixing some bug, you will go to a system admin. But for your day-to-day activity, like installing some software, renaming certain things, deleting some files, are you going to an admin every day? No, you should help yourself, right? That's the same way in an organization. There might be a need to administer your cloud, but for running all these applications and tools and doing some automation, you also need to be familiar with how cloud works. It's not into the administration, but you need to know how the regular operations work so that you know which machine to create. You need to know how the network works. You need to know how storage works, what storage to use, and something goes wrong, you need to know how to fix it. So this is where in the market, as part of DevOps, they are not going to just expect you to run tool like Jenkins or run a tool like Terraform or run a tool like Kubernetes. But you should also know where it is running, and to run, what are the things that is needed on the cloud. So do you even know what is the type of machine needed if you want to run Jenkins or Kubernetes is also one of the expectation which companies are getting into. Okay. Now, this is where all these strategies put together, a company will be able to now achieve the complete automation. So that to summarize all these things, what and all we have. So you have continuous development to help the developers do parallel development, infra as a code to ensure you create the infrastructure automatically on any cloud and scale. Configuration management will help you to make sure those machines which is created by IAC is configured. And then with the help of a concept or a strategy called CI, you will be able to automate the build and create a deliverable, but it needs to be more of a deployable artifact, which is where we use containerization. But again, this containerization will not run on one machine. So you need a group of machines in which you need to manage. And that's where a tool like Kubernetes or orchestration comes in. But how do you combine all these 3 to 4 things that we are talking about: CI, containerization, and deployment? And that's where we use continuous delivery, which is about integrating all these things together, which is called as CI/CD. Right? Now, after that, we also need to make sure that those machines and applications and services are monitored, which is where continuous monitoring comes. And we need to enable that there is a security at every level and at every tool we are using, which is DevSecOps. And finally, where are you going to run all these things? It will be on some cloud. So on that cloud, you should also be knowing how the basic operation works in terms of how the machine works, how the storage works, how the network works, so that if some issues are there, you know how to debug at the first level. And only then you go to an administrator and take a help. Okay. So that's what an organization is expecting. And finally, now, okay, all we understood so far is what are the different strategies that a company would be adopting. So now, like a buffet I said, a company needs all the 10 strategies. And for us, we need to learn all the 10 strategies. But the question comes is, if you go and just Google in the market, there's hundreds of tools. So which one you should take? So especially for those who want to switch your career or move into DevOps, what you should first do is keep it in mind. You need all the 10 strategies to learn at any time. But in that, while you're picking a tool, now don't take 2 to 3 tools to learn. Take one tool per strategy, and that tool should be a latest tool, because the mistake which people do is you try to take a tool which is very old and most of the people or in the interview will not be using, then you'll be wasting your time. So when you try to learn, choose a tool which is most popular in the market. Because if you take one tool, most of the other tools will be always in the same way. For example, I want to teach someone how to make a call on the phone or a smartphone. I should just give him any smartphone, right? So once they know it, they should be able to use all the other phones. The same way here, you need to know all these 10 strategies, but in every strategy, you need to choose one tool. So that's where pick one tool per category. But now the question comes, which one? So the tool that you're choosing should always be latest, and also focus whether that tool is supported or suggested by Cloud Native Foundation. Because Cloud Native Foundation is a community or a group which focuses us on all the open source projects which are related and which will work better on cloud, specifically for cloud. So that's where if you are learning, rather than picking up some random tool which is enterprise tool, it will be difficult for you. Pick up a tool which is more open source, which is latest, and take a tool which is more supported from the community called CNCF. Why? You will get a lot of examples and support when you start reading in the Google, because there's a lot of forums that will do. So that's how you should pick a tool. Okay. And this is where now if you go through for continuous development, you have GitLab or GitHub. Infrastructure as a code, you have Terraform. configuration management, we have Ansible, and talk about continuous integration, we have Jenkins as well as GitLab coming up. And for containerization, Docker is still the best tool. And for container orchestration, we have tool like Kubernetes, which is leading in the market. And to do the CI/CD, along with your tool like Jenkins, you're going to use a new GitOps way of using tool like Argo CD or Spinnaker, which is again in the popular. And again, monitoring. Now I don't want to do, but in monitoring, one of the popular tool that we have is Prometheus and Grafana, which is kind of able to monitor machines as well as applications, right? And from the security wise, again, there's a bunch of tools available. So this is how picking a tool which is cloud native and latest is very important. Okay, so now we understood what are those 10 strategies and somewhat what are the tools that we have in the market. Now there is another big question that comes into everyone's mind is coding needed for DevOps engineers? Yes, coding is needed. But let me tell you, coding is needed, but not programming. Why? Because as a DevOps person, you are not going to write programs, but you are going to help the people to write that program and help in how do you create the product and deploy. So that way, all you need to know is the knowledge on how the application works, how to build that product and how to test that product. So that's the only thing needed. But why did I say that coding is needed and coding is not programming? Because when we were talking about all these automations, right, for infra as a code or configuration management or for deployment, I was telling that there is a lot of files in which you have to put a syntax. So that syntax is also generally called as code. But don't get confused, that coding is not programming. Coding here refers to a small syntax which is easier for us to tell how the automation works. So that is not programming. So that way, regardless of what tool that you're using in DevOps, whether it is Jenkins, Terraform, or Ansible, or Docker, or Kubernetes, or even for monitoring, right? All those tools, you need to write some small files which will have some syntax. And that's where you will be having different files like YAML, JSON, TF, Docker files, or Jenkins file, using which you will do the automation. So now we don't call it as writing the file. We call it as developing the file because you're writing something. So what is that something inside the file? So technically it is called as code. So that's where in the market, people expect you that you have knowledge on coding, but that is not programming. Okay, so remember that. So coding is needed, but coding is not programming. And by saying it, the next question comes is, what is coding? So coding is all about knowing some syntax of a file, which is like a text file, a YAML or a JSON or a Docker file or a Jenkins file, in which you write some simple syntax which will help the tool to automate. Okay. Now, what's next? Okay, so now if you tell this, what is there something called a scripting? So should I need to know scripting? Yes, but it's not mandatory. So when you go to a company, now we talked about 10 strategies and different tools in it, using which you will be doing a lot of automation. But over a period, there will be some small activities for which a tool might not be good to use. Okay, a simple example I'll tell you. I want to connect to a machine and delete 2 files. For that, I can try to write an Ansible code. But instead of writing an Ansible code, I can just simply take a Linux command and run, and I can achieve. Or let's say I want to send an email. To send an email, there is no tool that will help you. So what you have to do in those cases, you need to use some Linux command and put it as a small script, which is again a small syntax or a code. So in those scenarios, having a knowledge on any one of the scripting will help you to do the automation better. But again, it's not mandatory saying that, okay, only when you know a scripting, you will do automation, but it's the need. So usually in organization, if you see, when you go to an initial level, you might not do such a kind of automation, but only when you start becoming more and more seniors and you're taking up more advanced automation. At that time, just using some tools will not be sufficient. So on top of that, there might be a small automation that you have to do, which is where scripting is needed. And again, which scripting? So there is no rule saying this is the scripting good for DevOps. All you need is an automation. So for that, if you know any one of the scripting, it is more than sufficient. So for those who do not have any knowledge on coding or any knowledge of any kind of automation, then we would suggest to start with shell scripting. But let's say you are already working on shell and you know certain things. To take it up a little advanced way, you can take Python. Or if you are more from a programming background, like a developer, and you already know things how to write a code like Java, C, then you can directly go with something like Go language, which can do things better than what a shell and Python can do. So that's how in a company, only when you have to do certain automation, there will be a need. At that time, you should be aware of any one of the scripting. Okay. All right. And now comes the part, how is that you can become a DevOps engineer? So with all these things in mind, all of us are not sailing in the same boat, because we have freshers, we have people from non-IT, or we already have people who have been working in certain things in DevOps, knowingly or unknowingly. So that's where now there is a step-by-step process on how do we convert ourselves in the learning path. So the first thing what we have to do is what I call it as the foundation. So in this, you need to first learn all the necessary prerequisites for you before you learn the actual 10 strategies of DevOps. So in that way, there are two things which is called as Linux and version controlling system like Git. So with the help of these two things, if you are aware of what is what, how does the system works, and if I give you some file, how do you store and manage using Git, so that will be sufficient for you to do the basic work. So this is what we call it as prerequisite. Now, once you finish, then focus on this 9 strategies plus CloudOps. That is why I said 10. But now don't jump into CloudOps immediately. So what you do, first, take any one of the cloud, regardless of AWS or Azure. You just need to know how to create a machine. That is sufficient. With that help, try to learn all these 9 strategies and one tool in each one of them. So that's how, whether it is AWS or Azure, preferably if you're a beginner, take AWS, which is much more easier, and then install your Git, Ansible, Jenkins, Terraform, Docker, Kubernetes, everything on that, and get familiarized with how this 9 strategies work and how this tool automates. And once that is done, then pick any one of the cloud, which could be AWS or Azure, and learn the cloud operations, which is where, okay, specifically in AWS or Azure, how to create a machine, how to create a storage, how to create a network, how do I give some permissions, how to do a backup. So that way, learn the cloud operations. And only when you have familiarized all these things, then get into the last step where pick up one scripting like I said earlier and try to see what are the automations that you can do and learn. So that way, it's not necessary that you have to learn scripting or cloud in the beginning. So first, prepare the prerequisites, learn all the strategies that we have on any one of the cloud just for using the cloud as a platform, and then use specific cloud of your choice and go a little deeper on the operations and finally come into the scripting. Okay. And now this is where on the market, there's another confusion, which is when you need to know the latest trend. So I was talking about this 9 strategies plus CloudOps, which is the 10th strategy. Okay. So for a minute, forget about the CloudOps. So let's focus about this 9 strategies. What are this? Continuous development, infra as code, configuration management, continuous integration, containerization, deployment orchestration, monitoring, and your DevSecOps and CI/CD, right? So now, when you go to a company, all these 9 strategies is definitely needed. Now for that, a company might use a cloud like AWS or Azure. Now I'm not considering GCP, looking at the fact that the usage is less, but you can also correlate to that. But on the percentage of usage, if you see the market and the openings, what you see between AWS and Azure are high when compared to GCP. So that way, let's not worry about GCP for a minute. Now, between AWS and Azure, when you go to a company will use either AWS or Azure, and they will be implementing this 9 strategies. So pay attention here. Now, this is where if you go to the organizations where they are using AWS as the platform, they will be using most of the open source tools, which is where they will be using tools like Terraform, Ansible, and for Kubernetes, in AWS, there is a service called EKS, and they will be using tools like Prometheus. So this will help to do the infra code, configuration management, deployments. But when you talk about the other side of working on agile or continuous development and doing the CI/CD, they will be using tools like Jira, GitLab, or GitHub, or Jenkins, and they will also be using some tools like SonarQube and JFrog. Now, this is where if you're learning these tools, typically, if you go to an organization where they have AWS as the platform, it'll be easy for you to showcase your experience saying, I will take AWS as the platform. So when I say platform, it's just a machine to take. But on top of that, you're using all these open source tools or an enterprise tool and implement these 9 strategies. Okay. But market has started changing over the past year or so. So this is where equivalent to AWS, Azure infrastructure is also capturing the market. So I won't say Azure is equivalent to AWS, but you can consider like overall, if AWS is around 38%, your Azure is close to 20 to 22%, which means it's catching up and it has a potential. So that is where when you go to a company, they can use either AWS or Azure as the platform. But now, if it is AWS, whatever that we are talking about is perfect, okay? Wherein 9 strategies is needed and they will be using more of open source tool. But this is the catch that's happening in the market. So the trend, what is happening is, if your organization is using Azure, they will implement 9 strategies. But out of the 9 strategies, Azure has its own service, which they use for certain strategies. So that is mainly in Azure for DevOps, there are 3 to 4 services which will help us to implement the strategy like continuous development, continuous integration, okay? And it also has something called as test, but that's not too much. So now if you look at this diagram, instead of using a tool like Jira, if you are working in Azure, so there is a service called as Azure Board, and that is what companies will be using because it's kind of much more simpler and it's easy for them to use. So they don't have to pay and manage it separately. The same way, for doing the continuous development, instead of using some tools like GitHub or GitLab, in Azure, they have their own services called as Azure Repo. So that way, they are still going to implement continuous development. So now, if you go to companies who are using AWS as the platform, that is where you will be seeing they will be using tool like Jira and GitLab for continuous development. But if you go to a company who is following Azure as the platform for continuous development, they will be using Azure Board and Azure Repo. Same way. For those companies who has AWS as the platform, for doing the process like CI or CD, they will be using a tool like Jenkins. However, for those companies who are working in Azure, they will be using a service called Azure Pipeline. Okay, now this is a small change what you would see. But other than that, what happens? Even if you're working in Azure platform, you will still use Docker. you will still use Kubernetes, you will still use Terraform, you will still use Prometheus and other monitoring tools. So that's how the majority of the tools, I would say 80% is the same. But the smallest difference between organization using AWS as the platform and Azure as the platform is for continuous development, they have their own service like Azure Board and Azure Repo. And for continuous integration, they have their own service like Pipeline. And to store that output, they don't have to use again a third-party tool like Nexus or JFrog. They will be storing everything into Azure Artifact. So this is how now when you try to target, if you prepare, you have to prepare 9 strategies. But in that 9 strategies, like what I said earlier, every strategy has one tool. So if you learn it, definitely that is going to help you only for the organizations where AWS is being required. What was happening until recently? Companies were saying, okay, I need you to know the 9 strategies of DevOps, and in that you should be familiar with any one of the cloud, which means whether I take AWS or Azure, you should be able to implement these 9 strategies and you should be aware of this tool. But in addition, specifically, there are organizations who is moving into Azure. So they are asking, do you have knowledge on Azure DevOps, which is nothing but along with this generic tools, do you have also knowledge on these specific services like Azure Board, Azure Repo, Azure Pipeline? So this is like 80% is common, only those 20% on continuous development and CI/CD is going to be different, because even in Azure DevOps, companies still need to use Terraform, Ansible, Docker, Kubernetes, monitoring. But what is that they are going to use? They are not going to use Jenkins, or they are not going to use Git or GitLab, or they are not going to use Jira. Instead, they are going to use this service. So that's where what is happening. Few companies are fine by saying, okay, if you know these 9 strategies with any one of the cloud, it's okay. But we also equally see there are organizations who are ready to pay you more if you additionally know these services in Azure. So that's where now if you compare, it is like DevOps on AWS platform or DevOps on Azure platform. And in that, specifically in Azure, for the continuous development and continuous integration or CI/CD, instead of using the open source tool, they will be using this 4 services, which is Azure Pipeline, Azure Board, Azure Repo, and Azure Artifact. So that's the smallest difference. And this is where now what is needed. So now if you want to make sure that your profile is being picked by any one of them, so the only thing you have to do is go back to the strategy that I said earlier. So once you learn that 9 strategies, additionally what you should do is learn these 5 services in Azure, which will help you to implement Azure DevOps on the organization where Azure is the platform. Okay, so that is how you will be able to now apply to any company when it says DevOps, regardless of whether they are using AWS or Azure or GCP. You will have knowledge of one cloud. You will have knowledge of all the 9 strategies plus one cloud ops of any one cloud. Plus, you can also target whether the organization is AWS based or Azure based. If it is Azure based, you just additionally learn that 4 services, which can help you to make sure your profile is wide. So that's how do you survive in the current market, is make sure that like a buffet, you have everything. Like just an example, I'm saying when you say sweet, some people might like a North Indian sweet or a South Indian sweet, or there might be people with have something like a Western style. So that's where have you seen, when you go to desert, they will have something like gulab jamun, and they'll also have some kheer or kesari plus some ice cream. So that kind of serves everything. So that's the strategy what we are saying. Okay. And now this is when, and I'm kind of happy to introduce that we have a new course curriculum that I'm personally calling it as a DevOps Ultimate Program. what's that we're going to focus? Now we're going to focus on all those things that I said, because now when you go to a market, we don't want you to struggle saying that my profile is not fitting into this organization because they are only into AWS or they are only into Azure. At the same time, you should not be with only the essential parts, because market is expecting more. So you should also be learning more, so that carry yourself as a buffet of knowledge. You should be able to easily fit whether a company needs focus on AWS or Azure, or is it on the core or advanced. You should be able to get everything. And that's where what we want to do is, in this 5 months of comprehensive program, we want to divide it into 4 phases, wherein the first phase, we want to give you all the prerequisites that is needed, regardless of whether you are a fresher or an experienced person or a person from a non-IT. What is that needed for you? We'll prepare everything from the prerequisite. And once it is done, the second phase, we will get into those 9 strategies that I was talking, and we will learn one tool in each of the strategy, which will be more open source and popular. And once it is done, on the third phase, we should now start focusing more on the advanced things. So what do you mean by advanced? Kubernetes is there. You have your Terraform. You have your Jenkins. Everything is there. But what's advanced is companies are expecting you have knowledge more on the administration side. So that's where, what is that you have on top of your Terraform knowledge, which can help you to do things much more better? What is that? Do you have a knowledge on Kubernetes administration so that I can handle the deployments much more better, right? On the same way, and this is where, like I said, also having the knowledge on those 4 to 5 services in Azure will also help you to be in a place where everything is same, so that now you already know tools like Terraform, Ansible, Docker, Kubernetes. But in addition to that, if you learn these services of Azure, you can also start putting your profile that it doesn't matter whether it is AWS or Azure. So that's where we are going to focus on the 3rd level. And what's on the 4th level? And this is my personal favorite, where I call it as job ready. All we are going to do is projects, projects, and projects. You will definitely get projects at every phase in 1, 2, and 3. But on top of that, now we are going to make it mandatory that you will have projects on top of all these things, which is not just a regular project, but more of a capstone project, which will combine all these things together. So that way, we want to make sure that you completing all the 4 phases, regardless of whether you are from India or from US or UK or Canada. Go back and look at all those things that I said will fit into the market requirement. So you don't have to struggle saying, hey, market is asking Azure, market is asking AWS, market is asking more on advanced of Kubernetes. And that's what we want to do. Have a knowledge in such a way that you should be a one-stop place wherein your resume and your knowledge should showcase right from prerequisites to all the essentials that is needed, plus the advanced side of your tools along with the Azure knowledge. And that's where it will be easy for you to get into a better position, switch to a better high paying profile, as well as in your current organization, you can move to a better position. Because what happens, the recession is only because you are not able to take up new work. So once you have better knowledge, you can switch to a better team or to a better project, or even when you are looking out, you will be able to compete with what is being requested in the market. All right. So this is where especially we have the first phase that I'm talking about, the prerequisite. So that we are giving it as a 7 days free class, which is personally, I call it as masterclass. So what you are going to learn in this 7 days is the complete phase 1. All the prerequisites and essentials that is needed, whether you are a fresher or from a non-IT background or for someone from an IT, because even though you are from an IT, you might not be worked on these technologies. So that's where what we will do in this 7 days, we will go through everything from the scratch so that you are ready and kickstart from learning all the concepts and tools that is needed later. So that's where we'll go into learning what is agile methodology, how does a release work, and How is that you do your day-to-day activity using Linux? And let's get deeper into the version controlling system with the help of tool like Git or GitLab. And it's also quite necessary that we should know how the application works, because sometime back I told you, you don't need to write a Java code, but you need to know how Java works. You need to know how the Java build happens. Okay. And how do you deploy Java? Same way. Is Java the only thing in the company? No, because you have front end and back end, and there is something called as a two-tier architecture, three-tier architecture, or a microservice. So you should also know them. And that's what we are going to do in the application essentials. And with respect to those, whether the product is a Java based or a Node based, you should be knowing how to build it, how to deploy. So this 7 days is going to be completely about getting yourself hands-on and understanding on all the prerequisites that is needed. With that, you can jumpstart and directly start learning those 9 strategies and tools like Terraform, Ansible, Docker, and Kubernetes. All right. And that's what we have. And